Here's our next problem. Please try to break this vector into its x and y components. First, we need to draw that right triangle. A right triangle that uses the overall vector as the hypotenuse, and where the legs are parallel to the axes. And we'd like to include this angle if we can. Here's that right triangle. Now we need to draw arrows on each of the legs. Well, the original vector was pointing up and to the left. So the legs should be pointing up. And to the left. We should label the legs. This leg would be labeled v sub x because it's parallel to this x-axis. And this leg would be labeled v sub y because it's parallel to the y-axis. We can use an asterisk to indicate the angle we're focusing on and the side that we were given. We can write down SOH CAH TOA. Never hurts to write down SOH CAH TOA. And let's make a plan as to which trig functions we're going to use. Well, we're planning to use the information we have about this hypotenuse. Why don't we label this as the hypotenuse? And this side would be adjacent, and this side would be opposite. We're planning to use the information that we have about the hypotenuse. Well, that would indicate that we want to use sine and cosine because those are the functions that refer to the hypotenuse. It wouldn't be too helpful to refer to the tangent because that won't let us use our hypotenuse number. The tangent doesn't refer to the hypotenuse. So we're planning to use the sine and the cosine functions. We know that the sine of an angle is the opposite side times the hypotenuse. So the opposite side equals the hypotenuse times the sine of the angle. And we know that the cosine of an angle equals the adjacent side over the hypotenuse. So the adjacent side equals the hypotenuse times the cosine of the angle. So we're starting to get into the hang of not always starting with the original definitions of sine and cosine, but instead starting with these forms without the fractions that are oftentimes easier to work with. So we can say that the length of the adjacent side is going to be the length of the hypotenuse times the cosine of our angle, which is 40 degrees. Or we can say theta if you wanted to, or cosine of 40. So we can either start with this equation, or we can start with the definition of cosine and then rearrange it until we get this, whichever you like. But most people eventually start getting into the habit of using this form. Now, what's our symbol for the adjacent side going to be? Well, v sub x. But I hope you didn't write down v sub x at this point, because remember that ADJ just stands for the length of the adjacent side. So it's really a very good habit to get into to indicate that with a dot. V sub x with a dot to indicate this is just the length or the magnitude. And then the hypotenuse would be 4 times cosine 40. And now we can simply get out our calculator and do that calculation in one step. Don't forget to keep putting the dot on top of the v sub x. So 4 times the cosine of 40 would be 3.1. Because this is a magnitude, it doesn't get a sign. Well, we're not done yet because what we really need is the sine component. When someone says to break something into components, they mean the sine components. Well, we can see that v sub x is pointing to the left, but we chose to the right as our positive direction. I just told you that that was the positive direction. If right is positive and the component is pointing left, it must come out negative. This is where it's really useful to have a separate symbol for the magnitude of a component and the full component. So we use the dot when we're working with the trig functions, because that indicates that the trig functions just tell you about magnitudes. But then as an extra step, we have to go on and figure out the signed component, and that's something we do by using the positive directions. Again, I strongly encourage you to use this dot when you're just focusing on the length, when you're just focusing on the trig functions, and then as an extra step, write down the variable without the dot to indicate when you're trying to figure out its sign. As usual, I just recommend that you try to copy in your own work the exact notation that I'm using on the board. All right, so we can build that into the sketch. V sub x is negative 3.1. Of course, v probably stands for velocity, so in that case, this would be negative 3.1 meters per second. I'm not going to worry about the units here. Okay, and then we have to go to the opposite side, which would be the hypotenuse times the sine of the angle. Hypotenuse times the sine of the angle. Again, you could just start with the overall definition of sine, but maybe you're starting to get comfortable with this form of that. So the opposite side here opposite side is v sub y, but again we're in the realm of lengths, so we should use a dot to indicate that that's a magnitude. And then a 4 times sine 40. 4 times sine 40 is 2.6. As usual, we're not going to worry about whether that's the right number of significant figures. Now, we don't want to write that this is v sub y. We want to write that it's the magnitude of v sub y with a dot. All the trig functions tell us is the magnitude. Then as an extra step, now we can figure out v sub y without the dot. Now we can just figure out the signed component. Well, up is our positive direction, and v sub y is pointing up in the positive direction. Well, I certainly hope that now it's clear what the difference is between a variable with a dot and a variable without a dot. Remember that the variable with the dot indicates a magnitude. Since magnitudes are always positive, there's no need to actually indicate the sign on a magnitude. It's probably better not to. On the other hand, if you indicate the component without a dot, then you're referring to the signed component. And then you should always indicate a sign, not just if it's negative, but also if it's positive. Remember that we always indicate signs not just in front of negative numbers, but also in front of positive numbers. The only time we're not going to indicate a sign is for a concept that would always be positive. Well, magnitudes are always positive, so we're not going to indicate a sign for that. How about this overall vector over here? Why is there no sign on that? Well, as I've already mentioned, there's never really a sign on the overall vector because you can only really determine a sign for something that's parallel to one of the axes. If you're parallel to the x-axis, then you should be positive. Or if you're anti-parallel to the x-axis, you should be negative. Or if you're parallel to the y-axis, you should be positive. Or if you're anti-parallel to the y-axis, you should be negative. But the overall vector isn't really parallel or anti-parallel to either axis, so there's no good way to assign a sign to the overall vector. So we're never going to assign a sign to the overall vector. And as a result, there's no need to put a plus sign in front of this because it goes without saying that it's positive. So should we call this v or v with a dot? Should this be v or v with a dot? Well, I'm kind of ambivalent about that myself. I'm not really sure what would be best. You can kind of do whatever you like as far as that's concerned. You might call it v with a dot to emphasize that this is just the magnitude. On the other hand, you don't really need the dot because there is no signed overall vector. So we don't need two different symbols for the overall vector because there's only one version of that. For the components, we need two different symbols. A component can be either signed or unsigned. So we need one symbol for the signed component and one symbol for the unsigned component. But the overall vector can never have a sign, so you don't have to be quite as careful with the symbols for that. Even if you don't put the dot on top of this, it's still got to be a magnitude because there is no such thing as a signed version of the overall vector. So I'm going to continue to not put a dot on top of the overall vector usually because the overall vector really, in this context, always represents a magnitude. It's never a signed number. But if you want to put a dot on top of this, I guess that wouldn't really be wrong.